In this short video, you will learn how to import Kentucky LiDAR data and create a model of the Mount Horeb Earthworks complex in Fayette County, Kentucky. Go to the DM Data Sources page on our website, scroll down and click on USA Kentucky to open the Kentucky Geography Network Open Data portal. Click on Browse and select the elevation entry from the list. The first entry in the list is the 5-foot digital elevation model, which represents the bare earth. Click on Link to go to the FTP directory. Check the index map to learn which tiles are within your area of interest. The Kentucky Geography Network also provides LiDAR point cloud data, which can be used to generate digital terrain models with a better resolution if the point density is high enough, or digital surface models showing buildings and trees as well. There is a tool on our website to help you with the download of the tiles. Click on Kentucky LiDAR Download Helper and run the application. Go to the Mount Horeb wiki page and click on Coordinates. On the top right, the coordinates are shown in different format. Mark the decimal value for the latitude and press Ctrl+C to put it into the clipboard. Paste this value into the appropriate field and repeat the procedure for the longitude. Choose the 5-foot DM option and select the width and height in meters around the central location to define the size of your area of interest. The table will automatically list the tiles that cross the selected region. Click on Download Selected Tiles, choose a folder, and wait for the download to finish. Open planlauf terrain and click on Open in the menu bar and choose the last entry, zip package. Select the downloaded zip files and click on Open to unzip the data. planlauf terrain will notice that there was IMG raster data in the zip files and will show the Open dialog again. Select all files with Ctrl+A and click on Open again. Please make sure that GDAL is installed on your computer and check our manual for instructions about that. Accept the default file name for the merged raster file and click on Save. You can also accept the default settings in the GDAL dialog by clicking on Import Raster File. Click on Show in Bing Maps and drag the white dots to adjust the area that you want to import. If you choose the Local Relief option, a preview window will appear and you can drag the orange dot in the map to preview the Peter Village enclosure. Adjust the parameters and click on OK. Make sure that the Mesh Decimation option is checked and click on Import Grid Mesh to start the process. Click on Save and enter a name for the tile file. Planlauf terrain tile files contain the model data like vertices, triangles, normal maps, and local relief data. Click on New Terrain File in the menu bar and specify the tile file that you've just created. Since the terrain is quite flat, you can select a contrast value of 3. planlauf terrain files are text-based project files that reference the binary tile files and contain data about pins, tracks, and other project-specific settings. Save the terrain file by clicking on Save in the menu bar. Click on More and then on Tiles and Shading. Since we included the local relief data during import, this option is shown as a shader tab. Click on it to load the data and display the local relief. Click on Set Pin, choose a color, and click in the middle of the enclosure to add a pin. Click on Set Pin again or press the Escape key to end the pin mode. Click on More and then on Look Around. Adjust the vertical center point by moving the slider and start the look around. Now let's create a digital terrain model from the point cloud data. Go back to the Download Helper, choose the Point Cloud Data option, and start the download of the LAZ files. Click on Open in the menu bar and choose the Point Cloud Data file type. Select both files, click on Open, and wait until the data has been loaded. There is some noise in the data, so please adjust the elevation max value to exclude the points outside of the relevant elevation range. Since the data is in a foot-based projection and planlauf terrain can only work with meter-based data, you'll have to reproject it. Click on Reproject and then on the EPSG 3089 option in the dialog. If you want to create DTMs or DSMs with different settings, you can save the reprojected point cloud data in a binary format, which can be read faster than the original LAS or LAZ files. Click on Classifications and choose only the ground and the water points. Apply the changes to update the viewport. Choose the Digital Terrain Model tab, set the resolution to 1 meter, and click on Create Digital Terrain Model. After the process is finished, the Import Grid Mesh dialog appears, and you can perform the same steps as with the standard 5-foot data before. Create a manual track from the enclosure to the Mount Horeb Site 1 and start a fly-through. That's it. Please have a look at the manual to learn about all the other features of planlauf terrain. If you have any questions, please send us an email to terrain@planlauf.com.